Okay, welcome to Mrs. Nikolash's science class. We are in the beginning stages of developing a toy that demonstrates the movement of potential energy to kinetic energy. Guys, can you tell me what you got going on here?
We don't really know yet. We're still kind of trying to come up with what we really want to do.
Okay. Do you have any ideas as to how you're going to demonstrate your toy?
Well, we're kind of trying to get, we're thinking about getting the thing duct tape perfect, like, and then getting the cups like this so they can actually go.
Roll.
And then we can actually make some other observations with our other materials.
Excellent. Have you thought about how you could use those lids? What purpose could those lids serve as? They're kind of hard. You sound like you have a really good invention there, but I wonder if those lids could help maybe the movement at all. Trey, can you tell me what you're working on and what your plan is here?
I really don't have anything yet. I'm kind of getting up an idea of how to connect the cups and then use it as kind of a catapult kind of thing. You know, I had planned that we were going to put these lids on the bottom so we can use it as a slide-ish kind of thing. But I just marked the cups and
Awesome. Thank you, Trey. This group, girls, can you tell me, can you explain your design and how it demonstrates potential and kinetic energy?
we're not really sure yet because we haven't got it done yet. We're just playing around with it, but we're going to sometime find out.
And you're going to collect data?
Yes.
Okay. Boys, can you explain basically what your design does? Hey guys, can I have it a little quieter so I can get some video? Thank you.
We're going to make like so that we're gonna have weights there.
Oh, good thinking. Good thinking. Okay, boys, what's going on here with your design?
I'm making a catapult.
Oh, a catapult. And how is this demonstrating the movement of potential to kinetic?
The rubber bands will be stretched with potential energy, and then when released, they will go. It will fling the bead.
Oh, good thinking. Good thinking. Girls, can you kind of give me the gist of what you're doing with your assignment, with your project?
We're gonna make a cannon.
You copied us? Or we copied you?
And the bead will go on the pencil.
Ooh. Look at these women engineers in the field. Good thinking, ladies. Love it. All right, guys, what do you got going on here? You want to demonstrate?
Well, we're going to take this chunk and we're going to like cut a thing into it and then we're going to put the rubber band down there. We're going to and we're going to slide that.
Yeah, we're going to make a car out of this.
Oh.
And it's, yeah.
Okay.
We're going to demonstrate because it'll
When
pull
we
back.
put it in there, then the potential energy in the rubber band will be kinetic and it will pull the car.
Okay. Awesome. Awesome. Can you girls go ahead and tell me what your design entails?
We have the whatever it's called right here. One second. Paper clip. And you stretch this.
Oh.
And get the pencil back in here. And then if you pull the pencil out through the bottom, it'll shoot it.
Awesome. Nice job. So now what's your next step? You have to make one little change on your design and then test how far your rubber band goes again, correct?
Yeah.
So you made a rubber band gun, so you're going to make another little change and see how
I
that...
think I'm going to put the pencil farther back so it'll stretch it.
Great idea. Good thinking. Look at you girls can be engineers.
We have an idea. Okay.
How's it going over here?
Good. This is how our idea went so far. Where'd it go?
That is an awesome idea.
Oh, you got the bead!
Awesome. Okay, so now how are you going to change your design to make it go further?
We put it back, Lindsay.
So now you need to start gathering data. You need to start making a data chart. You got a great thing. Good idea. Who thought of that?
What?
Who thought of that?
Photoshop
Good
it.
thinking, Dana.